Do you remember how to solve equations in trigonometric functions? And we did it in the last unit, but now this unit, I want to really spend an awful lot of time on this. And one of the reasons why I want to spend an awful lot of time on this is because then we're going to look at practical applications of this. Yes, practical applications of all this stuff. It's very, very cool. So how do we solve something? Well, these are all called first degrees. And the reason why they're called first degrees is because there's no squares in them. Okay? Squares or cubes or anything like that. There's just plain old to the power of 1. How do you solve this? Well, remember in algebra, there was a very distinct way of doing this. Okay? The way you do this is very, very simple. You will go out and isolate the x. Well, guess what? It's isolated already. The second step you would do is you would go out and you would use the cast rule. And you would say, add sugar to coffee here. And you would find out that this guy, in fact, is a negative. So negatives for sign are here and here. Then, after you finish that, you would take the absolute value of this and go, okay, so where is sine x equal to 1/2? Okay, where is sine x equal to 1/2? And you remember specifically, if you remember your nice little, yes, your unit circle, you know, and I know it's this guy here, the short guy, because these guys are root 3/2, 1/2. Right? This guy would be a negative, negative, and over here, of course, would be our positive root 3/2, right? Negative 1/2. And you know that they're at a reference angle of pi/6. So your reference angle here is pi/6. That means this reference angle here is pi/6. Then you would go out and say, okay, if this then is 6 pi/6, because that's what pi is, and over here would be 12 pi/6, because that's what 2 pi is. You go one more to give you, guess what? Your answer is 7 pi/6. Or you go one back and your answer is 11 pi/6. There's your two answers. If you don't believe me, go back into this wonderful thing called the podcast. Go back here and check out chapter 4, which is what we just did, okay? Now, so you got two possible answers, this one and this one, right? All based on solving and absolute values and all that other stuff that we talked about in the last unit. Okay, so let's go then to this guy. How do you do this guy? Same nonsense. Again, isolate, isolate, isolate. Solve for just secant x. So this is 3 secant x equals to 5. Bring the 5 over. Divide all of them by 3, right? So you're going to get secant x equals to 5/3. Now, remember what secant is. Secant, right, is the inverse of cos. So all you have to do is flip this guy and go, okay, so I've got cos theta, or cos x in this case, right? Might as well use it and be consistent. Cos x is going to be 3/5. Now, I know what you're saying. Well, how do I figure out 3/5? That's not one of the unit circle ones. Yeah, so what? Don't worry about it. We'll do that in a second. Hold on. Now, watch this. Okay. Where is cosine positive? Because, in fact, this is positive. Look at this. Positive here. Add sugar to coffee. There you go. It's got to be positive here. So you're talking about an angle here, and you're talking about an angle here. Got it? Okay. So you absolute value this now and find the inverse of cos. That's it. Just find me x. You're going to get some sort of value, and you're going to be in degrees. Okay, I can do that. Bringing up your calculator now, take a look. My calculator, unfortunately, right now is in radian mode. I don't want it to be in radian mode. I want it to be in degree mode because remember, the parameters of this question was degrees. Okay, so put this into degree mode. Boom, mode. And the funny thing is, and this is the frustrating thing is there's no real easy way using a TI calculator. You have to go into that mode. You have to play around. I would just love a button where you can go click, click, and you're in and out and you're done. Okay? All right, so let's go back to this. Now, we're going to solve for this now that we've absolute valued it. Remember, this has to be a positive value. You determine the positive and negativeness based on the cast rule. Once it's done, the positive and negativeness is done on the cast rule, leaving the negative in there is just redundant. You know it's either here or here based on the value of this number. Okay, so how do we do this now? Inverse coast, both sides, right? Inverse coast here, inverse coast here. You got an x equals to some sort of reference angle. So I'm going to take 3 over 5. I'm going to inverse coast it. So here we go. Second cos 3 divided by 5, right? Oops. Come on, you. 3, there it is, divided by 5. There, that's better, right? Confirm it. Yep, 3 over 5, punch it. Let's see what we got. We have 53.1 degrees. Let's round it to the nearest degree, 53 degrees. Okay, so that means this is a reference angle of 53 degrees. That is a reference angle of 53 degrees. You're between 0 and 360 degrees. Okay, so one of your answers, of course, is going to be 53 degrees because that's a real nice answer. Bada boom. But what about your other answer? Your other answer is going to go all the way around to here, right? So in fact, this is 360 degrees minus 53 degrees because it's like going all the way here and then back 53 degrees, right? Okay, perfect. Let's figure that out. That's going to be 7. The 5's cancel to give you 0. That's going to be 307 degrees. So the other answer is going to be 307 degrees. So you got 2 possible answers which are within this domain restriction. Okay, with me? Great. Okay, but what if I asked you for the general solution? What if I asked you, what is the general solution to this? Don't forget, all you have to do is add multiples of the period. But you take each one of these separately and add the multiple of the period to it. Okay, the period, of course, being, well, this is sine, that's got to be a period of 1. Okay, so there's your b, which is 1, which means your period. Okay, your period, of course, is going to be 2 pi over the b value. Oh, duh, it's just going to be 2 pi. So take this 7 pi over 6. You're going to go plus or minus, right? 2 pi times a k value. And your k value, of course, is going to be an element of the integers. Now, if it's an element to the integers, my question is this. Do you really need the plus or minus? Actually, all you have to do is hit a plus. 2 pi times k, and your k value is an integer because your integers automatically mean negative numbers. Okay? Take the other solution. This would be 11 pi over 6. You're going to go plus 2 pi times k, and again, k is an element of the integers. Now, I like using k's, but I notice some textbooks out there like using n's instead. So what? This one's in degrees now, right? So remember, general formula would be take the 53 degrees now, plus multiples of 360, because that's spinning you around that nice little unit circle. So k times, oh, I said I was going to use n. All right, so hey, I can't go back on my word here. N times 360 degrees. That covers all of them over and over and over again. Look, this is 307 degrees plus n times 360. And just don't forget to tell me that n is an element to the integers because you want all the positive values and you want the negative values as well. Okay? Now, my question is, how do you do this graphically? Well, guess what? I'm going to save that for the next podcast.